Okay, guys, last time we discussed the last concept that we discussed was, what is it? Interpolation and extrapolation, yes? What was interpolation and extrapolation, guys?
Interpolation is when the point is within the given data set and extrapolation is when it's not.
Sorry, interpolation is within the?
Within the range of the data set.
Yeah, within the range of the data set, what do we do?
You
Sorry?
find the point.
You find the point. What point? You have any idea, Ma? What did you do with interpolation and extrapolation? Yes, within the range is correct. What do we do within the range? Yeah, actually within the actual range, yes, in the data set, we are going to estimate, or we are going to run the regression, or we are going to calculate the value of the dependent variable by using the independent variable. What's the example we took? This is the example we took, yes? Yeah, see what I showed you last time? Basically, guys, this is the plot or the scatter plot that has been given. So these are the actual values. What do you mean by actual values? These are the actual values of the or actual prices of the vehicles that were used within 1 to 8 years, right? So we have, what are we trying to do here? We are going to develop an equation, or we are going to develop a relationship between the age of the cars in years and their values. Obviously, we know the value of our cars will decrease as we use. So then it is giving us a negative relationship. Then we are going to calculate the values of the cars, assuming a particular age for the car. So if that age is going to the anticipation or the estimation that we are going to use is going to be within 1 to 8 years, we would say it is, what is it, Christian? Interpolation. If it is outside, extrapolation. Right? So we are going to say, look, what if our car is 10 years old? And then we are going to calculate the value. That's going to be what? Inter or extra? Extrapolation, right? If it is 6 years, it will be interpolation. Why? Because the actual data plot is based on 1 to 8 years. That's the thing. Okay. All right. Then why do we make why do we want to make always interpolation calculations? Reliable, right? Reliability is high. Why? Because our actual data plot is also based on that range. So if you are going to go outside the actual range of the data plot, we are going to say it is unreliable. Okay, now we discussed this one, guys, before. Coefficient of determination. What is coefficient of determination? Yes. What is it? Tell me. Coefficient of determination. Tell me. Or you forgot the coefficient of determination? Seriously? My God, you are forgetting. Forgetfulness. Have you forgotten the calculator? Good. You are serious.
Nice, but again, you want to learn.
Right. So, I think you are the only one who wrote last week, yes? Oh, you also did it again? No, you wrote it. Oh. Not that one. The class. Yeah. Alright, guys. Then, what is coefficient of determination? Yes. What is it? R square. What is R square? What is R?
R is the correlation code.
Correlation coefficient, which explains the. How does it explain?
Between the two variables,
Variables. What variables?
X and Y.
X and Y. Oh. Which variables? Tell me another name.
The dependent and independent.
Dependent and independent. Or tell me another one. Sorry? Explanatory and the response variable. Yeah. Good. Alright, guys. Then this is the that's the coefficient, correlation coefficient, right? R, which is ranging from what values?
-1 to 1.
-1 to +1, and then R square, D square, guys. So that R value you will get in terms of R square. Always it's a positive value, and also we usually give it as a percentage. What does that mean?
It represents the relationship between how much the explanatory variable explains the response variable.
Yes. What percentage? Correct. What percentage, or up to what percentage the changes or the variations in the response variable is explained. Yes, explained by the changes in the explanatory variable. Is it okay? Right. So everything, I'm just reminding you, okay, what we have done. So you want us to do any questions or examples? No, you okay? Huh? Right. Then this one, residual plot. What did we say for the residual plot, guys? Yes, what's the residual plot? Yeah, residual plot. Do you remember? Anybody remembers the residual plot?
It's the actual minus the minus.
Yes, actual minus the
Predicted data values. And then you plot them on the graph against
yes.
the explanatory.
Actual data.
It's the actual data. So actual data minus the predicted data, and then we plot that against the explanatory variables.
Yeah. Yeah, that's yeah. I just asked you I just asked you what residual is. Yes. What is residual? Do you remember I explained the last time? I showed you in the graph as well. Yes. What is it? What's the residual? You remember? Yes. Which plots?
Of the actual line and the plot.
Yes, correct. Residual, yeah, correct. So basically, what is residual, guys? Yeah, what you said is both of you are correct, on the correct track at least. Residual is when we run the regression, which is our relationship or the line, right? This is basically the red line is the regression, right? And then the residual is going to be the deviation or the difference between the values obtained from the estimation and the actual, right? the difference or the deviation in between the actual value and the predicted value. What does that mean? For example, have a look at this. Let's say, based on this regression line is always always an estimation. Let's say a car is 6 years old. What would be its value based on the regression, based on the estimation? What's the value? Christian? Oh, Maha?
12,000.
Sorry? 12,000? Maha, what do you think it is? It is 12,000. Yeah, I would say 12,000 or maybe 11,000, right? Right. So I'll take your answer is correct. 12,000, 12K, yes. Right. But based on the actual value, how much it is? Actually, how much it is if it is 6 years old?
7,000.
7,000, correct. Right. So actual value is, guys, what is it? Actual value is 7,000, whereas predicted value is 12,000. That means we are going to subtract this one. So the residual is going to be how much? 5,000. But this one we will say minus. Why? How we calculate the residual is, guys, always actual take away predicted. Got it? Right. So have a look at the example, right? The actual price of 6-year-old car is 6,500. And then calculate the residual when its price is predicted using the regression. 3,500, take away this one. Right, then what do we do, guys? We will substitute the 6 years. Which one are we going to substitute? 6 years or 6,500? 6 years, yes. Right. So I told you we are always going to predict the value of the predict the y value or predict the response or the dependent value by changing the independent value. So then independent value is 6 years, which is the age. Age is independent. So then instead of 8 here, we are going to use 6. Then we can calculate. So predicted price is going to give us 11,460, which we said, which you guys said 12,000. And then the actual price is, we said 6,000, but it is technically 6,500. Right. So then, however, remember our residual was 5,000, which is also correct. So it is 4,960. Yep. So we calculated, what is it? Minus 5K, yes? What we calculated here, see? We said it is minus 5K. But according to the question and according to the real values also, they have got the same thing. 4,960 negative. Okay, guys, then example 5, what is it? Okay, now there is another story relating to this one. We call, guys, linearity assumption. Okay, linearity assumption. Linearity assumption is basically when we, okay, now remember we calculated the residual. Like that, I mean, we calculated only one. Makes sense? We calculated only one, yes? Like that, along the all of them, right? We can calculate the residual plot. Okay? Now this is the residual plot. Look at this one. Residual is ranging from positive to negative, yes? It is having both positive and negative. Right? Then, now, we are going to actually, we are analyzing the residual plot as well for to evaluate something. To evaluate something, right? You know what it is? That thing is the linearity assumption, right? What does that mean? Look at, now have a look at this one, guys, right? If, right, if the right, right, let's say if the residual plot is a random one, like what? Like this. Or same thing here, I think they have drawn. Or is it the same thing? No, it's a different one, yes? Yeah. Now look at this one. This one, guys, is for regression, what we drew for the car prices and their age. Now see, can you see any clear pattern in the residual plot? Or do you think it is something random? Yeah, everywhere, yes? The plot is everywhere, isn't it? Can we see any clear pattern? No, not really. It's everywhere. So if it is random, guys, that means perfect. We would say the relationship of our two variables is, what is it? Linear, right? The relationship is going to be linear. We don't have any problem. no hesitation to say that the relationship between the um, age and the car prices, for sure it's linear, right? No problem, right? Why it is, I mean, everywhere. So it's random. However, all right. However, if we come across any clear pattern, now have a look at this one. Right? A clear pattern is there. What is this one? I'm sorry, this is the residual. This is the real one. Actually, this is the regression, okay? This is the regression line. This is the residual. This is the residual plot. But this one, what can we say, guys? Can we see a clear pattern? Yes. Yeah. So I can identify a clear curvy or nonlinear pattern. What does that mean? If it is something like that, guys, see, if the plot is, sorry, if the residual plot is something like this, it shows a kind of a clearly identifiable curve. So that means, what is it? So if it is like that, that means we would say, right? This one we would say this is a non-linear. This regression line is non-linear. It's not linear. Why is that, Christian? Why do we say like that?
Because it doesn't follow a straight line. It curves.
Which one doesn't follow a straight line? Second one. No, not that. That's not what I said. What did I say, Mark? I told you, if there is something with the residual plot, yes, it can be the regression line can be linear or non-linear. What did I say? If we can identify a clear what's it? If we can identify a clear pattern, right? See, we can see a clear pattern in the residual. That means if we find a clear pattern, what is it? It's non-linear. Okay, the residual, the regression line is not going to be linear. It will be non-linear. Okay, that's the thing. Yeah, see, in summary, if a residual plot shows evidence of some sort of systematic behavior, a pattern. In the previous one, what did we see? Yeah, we saw a clear curvature. That means, what is the story? Then the relationship will be, yes, ma, what is the relationship? Non-linear. Okay? Right. Right. Then, guys, we'll go through the examples. Right. What would you say for example 7? Yeah, which of the following residual plots would call into question the assumption of the linearity in a regression analysis? What would you say with A?
A is linear.
A is linear. Good. Ma,
Okay.
yeah. So when you look at the residual plot, so what do you say about the linearity?
It's linear.
Linear? Yes. What did you say for B, Maha? Why?
It's which island?
Clear pattern. Christian?
Yeah.
Yeah. Clear pattern, yes. See, there is a kind of clear pattern. Good. Then C, Christian?
C is linear.
Linear. D, Maha? Non-linear. Why? Because we can see a clear pattern here actually. Yep. Curving down. Yep. Residual property is random, so linear assumption is met. Clear curve in residual, so linear assumption is not met. Yep. So basically, what we said is correct. All right. Basically, guys, that's it for this chapter. So this is the summary. How did we do, what did we do, guys, in these two chapters? We started this one from chapter 2, right? In the middle of the chapter 2, and we came to chapter 3. What did we start in chapter 2? Christian?
We started the
No? What did we start? Come again?
response and explanation.
Response and explanatory variable. Yes. What else? Before that,
Categorical and numerical data.
categorical numerical data. Yep. Yes. Yeah, you are correct. Christian, what did we start, guys? Firstly, we tried to construct a scatter plot. Why? Because scatter plot is the method, the only method for us to identify the relationship between two what? Two numerical data. Okay, all the other things we discussed before. What is it? We discussed about the two categorical, one categorical, one numerical, and so on. So this is the situation where we use the scatter plot for what? For us to draw the for us to identify the relationship between two numerical data. Then by investigating, what did we calculate it, guys? Correlation coefficient, right? Correlation coefficient is giving us the, what is it? The strength of the term, and also it shows us whether it is linear, non-linear, and also whether it is the form. Yes, whether it is going to be positive or negative. Yes, everything is given by the correlation coefficient, right? Then after that, guys, we determine the equation of the regression line. Yes, how did we do that? Basically, we calculated. We use the method y equals, yes. What's the equation format? Y equals
A plus B.
A plus B. What is A? Christian?
Y.
Y intercept. What is B? Maha? Slope or the gradient. Good, wonderful. Right. So then, unfortunately, remember you guys didn't have the calculator, so that we couldn't do that, right, in the class. But you must be able to do it. Practice it at home. If you have a problem, let me know. Then after that, we determine the equation of the regression line, and then after that, we calculated the, what is it? Correlation coefficient, yes. Right. Right. Then also we calculated the coefficient of determination, and then finally we did guys the residual plot, and then we test the assumption of linearity, and then finally we are going to write a report on our findings. Have a look at this is how the report there is going to be. Okay, shall I explain you? Now, see the first one. We investigated the nature of an association, right? Right. So from the scatter plot, there is a strong negative linear association between the price and the second-hand car, which is R. Correlation coefficient guys negative 0.96. So then it shows strong negative relationship. Then the equation of this regression line is this one, and then slope is 3940. What does that mean? On average, when the age of a car increases by 1 year, what will happen? The second-hand car's value decreases by 3940. Then intercept is, what do you mean by intercept, guys? The price of the cars when it is, yes,
When it's
brand new. Yep, that is when age is 0. The coefficient of determination indicates 93%. How do we calculate it, guys? Negative, yes, 964 is squared. Then we got 93%. So meaning 93% of the variations in the price can be explained by the variations of in the age, which is determined by the coefficient of determination. And then finally, we did the residual plot. What did it say? The clear pattern in the residual plot confirms that the assumption of the linear association between the price and the age of these second-hand cars, right? So then we can say definitely there is a linear relationship. Okay, guys, that's it for this chapter. You have any questions? Nope. Then we'll do some questions. Firstly, we'll do question number 11. Yeah, if you are done, Christian, you can do Question number 13. Sorry. Page number in this one it's 191. You are done? Okay. Okay, now you done?
Yeah.
Okay, guys, if you are done with this, shall we discuss? Right, 11A. Yep. What did you say? Yeah. Which of the residual pros suggests the use of linear model to fit the data was inappropriate? Why? A. Why is that?
Because the data has a clear pattern, meaning it is going to be.
Very good. So this one we can see the clear curvy pattern, right? That shows the relationship between these two variables may not be linear. Maha, what did you write for this? Sorry? Option A. Yep. Where you had to explain why. Yes, curvy shape. So as a result, we can see a clear pattern. So that it suggests that it doesn't have a linear pattern. Good. You guys can do question number 13.
There was a name about what a question.
Yeah, slope of this regression equation and interpret. What's the slope here, Ma? 0.278. Negative. Make sure you are writing for the slope, positive or negative. Then interpret. You have to explain. Remember, we have done it before. How you know how to explain it, interpret it. Or you need to help you. Yeah, you need help. Yeah, how did you explain it? Did you do question that part? Part A. How did you do?
I got negative 0.278.
Mm-hmm.
And for every 1 centimeter of distance added, the golfers would be 0.278% more likely to miss on average.
Yes. Is it clear now? No? No? No. Okay. So basically, what does it mean? Okay, I won't tell you this one. I'll tell you another one. Okay. Now see this one. For example, okay, I'll explain you from the one we were doing. Yeah, look at this. Now this is what we were talking as. If I was to explain the slope, what's the slope here? Negative 3,940. Meaning, so that means when the, listen, when the age or when the, basically when the age increases in the car by 1 year on average, the car price is going to drop by 3,940. Okay, now like that you have to equate for the question. We have done them before. It's not new that we are doing them. We have done it before. Yep. You done, Christian? Yes.
For our stats,
Yes.
should we be using our textbook as a boundary?
No, how are you going to do for bound reference?
Must give us.
No, school won't give you a bound reference, ma. Don't expect your school to give you. And also, even though the school gives you, even I can give you. I also have bound reference. I have made some for some chapters, not all of them. I have made for some chapters. But no point of using other people's bound reference. I know, like, sometimes you can ask it from, your siblings or your friends, anybody. So, bound reference. However, I know some people also use the textbook.
I'm thinking for the stats maybe it's textbook, but for the exam I'm gonna like have a proper boundary.
Okay, I think the best thing is, sorry?
Exam was set.
Yeah, what's the difference?
I mean, the SAT is only like only small chunks of the thing, so you only have to look through like one or two chapters. If you have the bad reference for your for the exam, it's like
then
the whole thing.
Yeah, so then exam will be hectic, yes?
Yeah, because you made it yourself, you know where to find the stuff.
So basically, yeah. So if I were you, I would make my own. The best thing is to make yourself, but I would say, Christian, rather than waiting for the exam, you can start doing it now. As you go on, now say you have finished 3 chapters, you can start long reference for it. However, if you want, you can carry both. You own one and the textbook, but you have to bind it together. You know what I mean?
Yes.
Because in case you think that you need some extra help, how do you bind it? Yeah, how you would bind this together is you take the song. So let's say the first page of the textbook and the last page of the textbook, you stick to this. You say you have to stick it, then we have a song. Let me know if you are done with this. Let me know if you are done. R. Yes, remember how we calculate R is
You know any of the chapters on so
sorry, Krishna?
do you know which chapters on the exam?
No, all of them are common.
Every single one?
Yeah, that's no choice with this one for you.
With exams, that is a year, right?
Sorry?
The exams ends a year, right?
Yeah. In usually general maths is going to be the first paper is last day of October, and then
Usually the weekend.
yes,
And then
then usually on Friday, then last Friday of October, paper one, which is 31st October, or can be sometimes 30th or anything. Then next first Monday of November, you'll have the second paper.
Why are there two?
Yeah, there are two papers.
But aren't the values, so,
Sorry?
but aren't the values because.
Yes. You can carry the bound reference regardless. For first paper, you'll have MCQs. There are 40 MCQs for 1.5 hours. Second paper is short answers. Also, you have 1.5 hour, 1 hour 45 minutes with reading time. That second one also has 1 hour 45 minutes. It's not 2 hours. Short answers. That one you have to write short answers.
And it's like, raise so like some sort of practice that you can do the financial math.
Yes. Financial maths, I'll help you. Right? Don't worry. Because financial maths, because your school is weird.
But doing financial math, you have to come from chapter 1. Okay.
Yes, that's the thing. Because some schools they do weird. They are starting from chapter
So
7. You know, they do chapter 7 and 8 first, and they do the SAC. Then after that, they come back to chapter 1. So your school is like that. You also like that question? No. Chapter 1, yes. Then for you, we'll figure out what we are going to do after this. Right? What are you doing now at school? Like which one?
F.
8F. That means you are going to finish financial maths.
So March 2nd, my first.
Hmm.
Yeah.
Okay. When do you have your set?
March 2nd.
March 2nd. Okay. Yeah. Yeah. Christian, when do you have your set?
March 11th.
March 11th. From which chapters?
I think it's chapter 1 to
1 to 3.
1 to 2, something like that.
Yeah.
Just to start.
Yeah, should be then 1 to 3. Not 1 to 2 doesn't make sense. 1 to 3 is how they usually do it. 1 to 3. Then, given that now she has financial maths, if you want, we can start today chapter 7. Otherwise, we'll have to do separately for you. I mean, separately. Yeah, because Maha, the thing is, now, if you are doing like basics, I could have started the chapter 7 today. That's what I was thinking.
I kind of got the hang of the basics.
Chapter 7, you are okay?
Yeah, I can solve some questions.
Okay. Otherwise, sorry, shouldn't be a problem. Yeah, he's happy to do 7 then. He's really generous. Yeah. Yeah, because some schools I know they are like they start from the chapter 7, you know. For me, it doesn't make sense. Yeah, but however, yeah. Okay. All right, guys. You guys are done with question 13? Yeah. Shall we discuss? Are you okay, Maha, with this?
I have to find the.
Okay. You asked me a question. How to find R? Now R squared is given. Then can you find R? Yeah. What do you do? You get the square root. Otherwise, how do we find R? Christian, do you remember the formula?
R is it sigma of
Yes. Minus. No, there is a.
sigma minus
Okay. Okay. If I didn't ask R, if I ask you B, you know how to calculate
B as in slope.
slope?
Yeah.
How do you find it?
Y bar.
Yes.
Y minus Y bar divided by X minus X bar.
No. Is that the one how we did B?
Yes. Thanks.
No. Part E? Yeah, so write down the value of the coefficient of determination in percentage terms. So what do you do? So now we have the coefficient of determination, which is? No, that is R, 0.7. So this one is what? This is the coefficient of determination. This one is as a percentage times by 100. So what is it? 49.7s. And then you have to interpret.
R is equal to sigma multiplied by X minus X bar multiplied by Y minus Y bar divided by N minus 1 times S of X and S of Y.
Yeah. Yes. And there was another formula. Do you remember? No, I'll show you. Just we will do this question after discuss.
Is it B S
Hmm.
Y divided by B?
Yes. Yep, correct. So B times standard deviation of y over standard deviation of x. Yes. Yeah, this is the one. Yes. B. This is how you find it. And also, similarly, you can find R as well. You can equate for R. Right. Okay, guys, shall we do question 13? Yep. Right. So what's what's the slope, guys? Negative 278. Negative 278. Negative 0.278, right? B. What's the answer for B, guys?
73.4%.
73.48%. Yeah, they haven't asked us to do it in one decimal. Okay, they haven't mentioned decimal place. That means how many decimal places do we leave the answer? No, one. Yeah, if they haven't told us, one, yes?
So 73.5.
73.5% then. Yep. Right. Then part C. What's the answer for part C, guys? In meters, okay? You have read the question. Some people have answered in centimeters. That's wrong. In meters, you will get 0 marks for that if you put it in centimeters. At what distance in meters? Okay. What is the answer for this? 3.5 meters. Calculate the value of R rounded to 3 decimal places. What's the R, guys? 0.705. Right? Then write down the value of the coefficient of determination in percentage and interpret. What is it? Coefficient of determination, what is it, guys? 49.7%. And what does it mean?
49.7% of the change seen in success can be explained by changes in distance.
Yeah, 49.7%. Some people have answered 0.705. That's wrong. Right? So what does it mean? So the, I mean, by 49.7% of the variations in the success rate can be, what is it? Success rate in putting the golf can be explained by the variations in the distance of the golfer from the hole. Yes. So 49.7% variation in the success rate input in the golf is explained by the variations in the distance of the golfer from the hole on average, right? So then basically that is what we say by the coefficient of determination. You want to do another question? Do 18 and 90.
What do you?
19. Yeah. Just trial, I'll help you. You are done, Krishan? Okay. What's your answer for 18? B. Um, right. Any other answers? What did you get?
I thought like, but I never was actually the
Okay. Right. Who is saying B? Akan and Krishan. You also saying B? A. Yeah. Unfortunately, all of you are wrong. Why? So all of you are saying, however, what is it? Your intercept is what? Is it 60? You sure? Intercept is 60? 70? So this is where the intercept is, yes? Is it 60? What did we say for intercept? When x equals 0. When x equals 0. So is that x equals 0 there? No, then what's x is?
X is 70.
70.
So
X is 70, guys. Yeah. So what you thought is, what is it? We said that is the place where the equation or the line touches the x-axis. So y-axis, yes. Yeah, we can see the y-axis is touching. But remember, y-axis should be is touching only when x is 0. Otherwise, it can't touch. See, this is 70, guys. That means it is not the equation. It's not the one. Then how do you find it?
Just substitute.
Substitute what?
Substitute. Make x equal to 0 and then substitute it into the.
Yeah, you can substitute into that, but how do we know which equation? We have 5. So are we going to equate all of them to 5? Again, we don't know if that is the value. Why? We don't know if it is correct. Yep. We don't know if it is correct. No, substituting doesn't work. Yeah. Firstly, guys, you know what you have to do? You have to find the What? Find the slope. How do you find the slope? How do you find the slope? Yes, you can make use your year 10 or year 9 maths knowledge, right? What is it? Yes, rise over on. Remember, guys, all of you remember rise over on? Rise over on. So that means you have to pick two coordinates. I would pick this one easily. I would pick these ones. I would say this one is going to be my first coordinate, or maybe I would say coordinate number 1 here. Coordinate number 2, I would pick something that is easy to calculate for me. You know what? Yeah, that's the thing. This is what I would pick. You know why? Because here I can see clearly the coordinates. I would say 115 and 110. That I would say number 2. Now you can do the rise over run. How do you do rise over run? Y2 minus, very good, Y2 minus Y1 over X2 minus X1. Now calculate the firstly, what is it, the slope.
Positive 0.91.
It's positive, definitely, you are correct, Christian. My Y is changing how much? 60 to 50. 50 over X is changing by 45. So I'm getting 1.1. 1.1. 1.1 positive. Did you get the same question? What did you get?
I got 0.9.
No, that's wrong. I'm getting 1 point. My change in the Y is 50. Change in X is 45. What did you get, Mom? 1.1. Okay, what did you get for the slope?
I got like
I can't hear you. Can you please type? This question, your answer is wrong. What have you done? Probably you have C. So basically, what is it? Change in Y. You know how I did? You know how I did? Like this. Yes, basically, change in Y. Yes, change in Y is from here to here. Change in Y is 60 to 110, which is 60. Sorry, 50. 60 to 110, 50. Then change in X is, what is it? This one, which is 45. So 50 divided by 45. So 1.1. So there are 3 with positive 1.1. Then the other problem is we have to find the, what is it? The intercept. If you want, you can find this intercept. How would you find the intercept, guys? Yes. Maha, how would you find the intercept? This is year 9 and 10 maths. This one you should have done that.
1, 7.
Yeah, y-intercept, how do you find it? X equals 0, good. So so our equation is y equals a plus bx. So then x is equal to 0. That means this this term will be 0. Anyway, y, how do we know y value? How do you know y value? Yep. Yeah, but this one, what we have to do is, if we apply with x equals 0, we can't find the value. So then what we have to do is, we have to find the value where the x value is known. Okay, x value is known. So then what would you do? You would pick any coordinate. That's it. If you want, you can pick 60 and 70. Actually, I would say here, guys, without calculating, I would say, what is it? Probably it's going to be E, correct. Even you don't have to worry about calculating. Why? See, look at the others. So we have only three answers with 1.1, which are A, C, and E. See? 1.1, 1.1, 1.1. But have a look. The first one. So for A, we have 60. Of course, we know 60 is wrong. Because why? X is not equal to 0. They are saying next one is 70 for part B, part C. 70. Can it be 70? If it was 70, it should have been here. No, that is not even possible. Why? Because the equation is even lower. That means, guys, for sure it is 17. But however, if you want to calculate mathematically, what would you do? You would pick any, look at this now. You would pick any coordinate, which is, I'm going to pick this one, 60 and 70. Okay? So then I would say y value is 60. How can I write it? Y is 60. A we don't know. B we calculated 1.1. X we calculated 70. That means we can simplify this one. 1.1 times 70 is how much? 77. So then it will be 60 equals A plus 77. Then if you simplify this one, you will get A is minus 70. So then obviously E. Now see, that question is not really a VC question. Year 9 or year 10 maths question. See, they have given it in the paper. This is an exam question. See, you got it wrong. All of you, be careful. Because everybody thought it is, what, 60 is touching the y-axis, then that you thought it's 60. Okay, right. 19 did you do? I think this one you need the calculator, yes? Right, you need the calculator. Then do 20. Done? Yeah. Everybody's done? Yeah. What's the answer, guys, here? A. 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 All of you have got a least squares line. Yes, that is, you guys are correct. Weight of the fish increased by 23.3 grams for each centimeter increase in length. Correct. Okay, guys, then 3C. 3C is going to that we are going to use the cas to run the regression line. So what do we do? Look at the steps. I think all of you have, except you, yes? You had a class pad? Yeah. You are having a class pad, but say similar thing, technically, right? You would be using new document, right? Then you have to enter the data one by one. Then you will get the scatter plot, right? Once you get the scatter plot, you can go to the menu and settings, and then you can calculate after that, analyze residuals, hide residual plot. So those ones you can calculate, and you can get the equation line and also the residual plot. Then it will give you correlation coefficient R and R squared. So if it is on the classified, guys, similar thing, you enter the information and then you have to pick up the what X value, X variable, Y variable, right? And then what do? You have to go to calculation, regression, and then linear regression. You'll get it. So this one is in the right. Firstly, once you have it, you know how to enter the data? No? Yeah, firstly, then you have to do this one. Uh, uh, yeah, you know how to enter the values now? No. How you know how to get this one? No. That means you will have to follow the previous ones from the chapter 2. Yeah, go. Try with control N. Do you have a control N? No. Crossword, I'm not very sure. Give me a minute. Crossword. Yeah, this one. Open the statistics application. You have it? Yep. Then after that, you have to label the columns. See this one? I have height, weight, in this case, right? Then yeah, then after that, you have to have that graph thing, right? That graph. Yep, graph thing, and then after that, you have to set up the stat graphs, and then you will get something like this. Did you get this screen? Yeah, then you have to pick what type scatter, X list. So you have to put height, Y list weight, frequency 1, and so on. Then you'll get this scatter plot. Yeah, then you have to technically follow the steps. Then from the calculation menu bar, you have to tap the regression and linear regression, and so on. Then you will get the information such as A, B, R squared, etc. Yeah, you have to enter all the information. Yeah, then you should get it. Yeah, so probably you try work it out at home. You should get it if you follow the steps. Yeah, let's start then chapter 7. Okay. Now this is, are you okay with this one? If you're okay, I'm not going to do. The basic thing is pretty simple, yes? So you are having some pattern, so it can be plus 2, and then so on. So we say that first term is
I just need how like the next parts like the depreciation, linear curve,
yeah. Yeah, then before that, Maha, you have to understand this, how we write the terms. You are okay with this?
Yeah.
V0 is the first term, Vn plus 1, meaning we are writing the recursion relation, right? So always it's going to be, so let's say we are going to find V2 or the second number 2, the second one. Then how we are going to do is now let's say if it is like this, Vn minus 4 is Vn plus 1. So that means if Vn we are going to say it's 2, then Vn is going to be 3. Yeah, minus 4, like that. We are going to find the term 3 with term 2 take away 4. Otherwise, if you are going to find term 2, then it will be term 1 take away 4, right? Like that. Otherwise, if
when you're calculating V1, is it the value after V0?
yes, correct. Yes, yeah, correct. V0 is the starting term. Yeah, starting value. Then V1 is the next one.
That's why we include V0.
Yes. I mean, if they ask you to write the first 5 terms, then it includes the first one, which is V0, starting value. And then the others are, now see, for example, this one, 29 is, what is it? V0. Like that, 25 is V1, V2, V3, and V4. Like that. Okay? Right. The others, are you okay? Yep. Christian, you are okay with this, yeah? So we did it last year as well. Right. These are you okay, yes? Hey, you always said okay. Linear growth, you okay? Yeah. Linear growth means what? Linear growth means our terms or our pattern increases in a equal value. Linear. Now see, that's why I say like your teachers, school is going to do this linear thing, then the students don't understand. Linear growth. Linear growth means we have a positive slope. See, linear growth, it is increasing. Yep, increasing. Linear decay, decreasing by an equal term. Now we'll see what happens. Right? See this one, P0, the first term is 20, Pn plus 1 is Pn plus 2. That means always if you are going to find the value, let's say if you are going to find the value of 10, then this one will be 9, 1 less, plus 2. Then, now see, every term is increasing by 2. Then, if that is the case, see, linear growth. Why do we say linear? Because every time it is increasing by 2. If it was non-linear, let's imagine it was a non-linear growth, then it will be something like this. Why? Yes, for financial less.
Would that just be like compound interest?
Yes, correct. Compound interest. Okay, now this one linear decay. See, linearly by equal term, equal amount, right? Equal rule. Rule is how we express this one. Now see, this is a rule. So rule is this, see, plus 2 is the rule. Always we add 2 to the previous term is the rule. That's the rule. Yes, formulas we will have in the future. This one is the simplest way. After that we will have formula. Okay. Yeah. Then right. So this is also recursion relation, right? So this is increasing linear growth, and this one is linear decay. Right. Usually, linear decays we will come across in financial maths with simple interest loans and investments. So we have a simple interest, right? Every year, what do you mean by simple interest, guys? Every year the value is increasing by a fixed amount. That certain amount is a constant, fixed, right? So now have a look at this one. Cheryl invest 5,000 in an investment account that pays 4.8% per annum. Simple interest. So model this simple investment using a recurrence relation. So then, guys, what we have to do is we have to calculate that amount. So this linear growth is expressed in this rule. What is it? Vn plus 1 is equal to Vn plus d. So d is what? D is the constant amount or the fixed amount. Okay, right. Then how would we calculate the are using this formula. D we will find, right? So V0, that means value at the beginning is which is 5,000. From that, we are calculating the percentage, 4.8% over, 4.8 over 100. Right? So it will be 240, yes. Right. Now, what's the rule? Rule is, now we can say rule is, V0 is 5,000, Vn plus 1 is equal to Vn plus 240. Why 240? Because that is by how much every year our investment increases. Every time it will be 240. Then what is it? If it is 240, guys, our first year this is starting, or when the time is 0, that means today. But after 1 year, that is V1, 5240, V2, 5480, and so on. So this is V3, V4, and V5 after 5 years. Today, that means V0, then after 1 year, which is 1, 2, 3, 4, and so on. Any questions? Now you ask me depreciation. Depreciation means what? Depreciation, first of all, value is decreasing as we use, especially for man-made items, value is decreasing, right? Maybe natural ones like land, value is increasing, appreciation. Yep. Okay. This one, depreciation also we can depreciate in different ways. Sometimes every year it is decreasing at a equal rate. If it is equal amount, sorry, not rate, equal amount. If it is equal amount, every year if it is reducing by equal amount, we will call, what is it? Flat depreciation. Right? Flat depreciation. Also, unit cost depreciation is also flat depreciation. I mean, like unit cost is also, the depreciation is always equal. So what do you mean by unit cost depreciation? As we use an item once, right, then its value will decrease. Okay. So we use it by 1 unit, let's say maybe motor vehicle, when we use it by 1 kilometer, value will decrease. Or if it is TV or laptop, when we use it for 1 hour, our value will decrease by fixed amount. Every hour we use, value is going down. That's called, what is it? Unit cost. Okay. Right. Now let's calculate the flat rate. Now have a look at this new car. So as we discussed before, purchase for 24,000 in 2014. Car depreciates 20% of its purchase price each year. That means how long would it take using your common sense, Maha, to depreciate the car to 0? How long would it take?
They give bad references for certain chapters, right?
Yes, but I have Christian. The problem is now for the previous study design because they changed it in 2013. I have it for the previous one, but some of them are actually still valid. Like the first 3-4 chapters they can be valid. I can give it to you, but I don't recommend it because you have to write in a way that you understand. Correct.
5 years.
5 years, correct. You are correct. Why? Because you know how you do it. So fully, if you use it 100%, right? But you are using every year 20%. That means 100% divided by 20 years. It will take only 5 years to depreciate in full. Okay. However, that's a different story. Different question I asked you, Maha. Right? Then how much is every year that it decreased by? 24,000 times by 20%, yes, which is 4,800. Every year, the car reduces by 4,800. That means we started, let's say we purchase it today for 24,000 after 1 year. So that means V0 is 24,000 after 1 year. It will be 4,800 less, which is 19,200 this time next year. Like that, every time it is decreasing 24. Then can we write the rule? Yes. Vn plus 1 is equal to Vn take away 4,800. This time it is not plus, it is less. It's still recursion, yes. Because why? Every year this rule applies. Every year the value will decrease by 4,800 from the value we had. Right? Then what will happen? Now, if we wrote the values, it's going to be this is V0, 24,000, then V1, 2, 3, 4. At the end of the last year, fifth year, yeah, at the end of the 5th year, it will be 0. Right. Then if you want, you can draw this one. If you drew it, we will have a linear relationship like this. This is the one. Like this, we will have it. Yeah. Then this one. Unit cost depreciation. For the unit cost, right, we don't have a percentage. Now, actually, this one is a VC question. We'll do VC when we are doing papers. We are doing papers, okay?
When do we start papers?
I'm planning to start, Christian. Last year I started early September, October. Yeah, we can start in August. Yes. So that means we should be able to do about 20 papers.
Do you make the papers?
No, I didn't. I haven't made the papers.
Where do you get?
I basically purchase from company papers. Yeah.
Where do you get them from?
I get it from different sources, like online. You have to purchase it online. So you can purchase. I have different companies. CPAP. Then there is one called Victorian Maths Association. That their papers are very standard. They are hard. Victorian Mathematical Association.
Do we also do the week of past?
Yes, the week of past papers, of course, even you can do because you have anyway those access to those sources. We can do week as well. Mainly, I focus on company papers, and then we can do Northern Hemisphere ones as well. You know Northern Hemisphere one? No, that's right. So there is another VC exam conducted for the northern hemisphere, meaning like people, especially who are in China, who wants to study here for the uni, the VCAR is setting a paper for them in the middle of the year. They do it in May or June, somewhere around there. Or we are doing that one. That's basically harder than we see. We are doing them as well. So,
Much do you need to process out?
sorry,
How much percentage do you need to process out?
what percentage?
Is it about?
It is, I think it is 40%. Yeah, check with your teacher. I don't know because some schools say it is 50%, sometimes 40%, but yeah,
51.
51. Yeah, that's the thing. Some schools say it's 50, some people say 40. Yeah, that depends with the, like, you know, the, I mean, the complexity of your papers. Some schools set it like harder, then they'll say 40%. Sometimes if it is, you know, easier, they'll say 50%. Yes, ask check with your teacher definitely. Yeah. Okay, guys, this one. Now, unit cost depreciation. Now, see, we don't have a percentage. Why? Every time it is reducing by a given value. See, this case, professional gardener purchased a lawnmower, 270. Mower depreciates in value by 350 each time it is used. Every time that man does a job, then the value of that will decrease by 350. Then what's the rule? See, Vn minus d. So Vn plus 1 is equal to Vn minus d.
Just be Vn minus
D. D is, what is it? 350. Right? So D will be anyway 350. Right? So Vn, if you are going to write for the first time you used, so Vn plus 1, right? Technically, if it is V1, then it will be V1. Vn is going to be V0. So V0 is how much? 270. Take away 350. It will be how much? 266.5. Yeah, like that it will progress. Yeah, see, they have written the first 5 terms, they have written 266.5. This is what we calculated. This is V0. This is V1, 2, 3, 4, and this is V6. That is all. What is it? Linear decay. Right? Linear decay. That's for 7b. Then using an explicit rule for linear growth. Yeah, same thing that we said. Explicit means
So what about example? Do I just write the yellow parts?
yes. Yes, you can. Yes. You can put examples, you can use questions, the reference book as you wish. As long as it makes sense to you, it's for you. And if you came across like you know, hard question or interesting question, also you can put it in the reference. That's what I would do. Yeah, there are some questions that I would include. Yeah. Now, explicit rule means, what does that mean? Now, I will apply for that lawnmower thing. Now, let's say we wanted to calculate the value of the mower after 10 use. That means, what is it? V10. Then V10 you are going to find straight away, rather than writing that whole steps, right? Because it will take ages. Rather than that, you are going to do, what is it? From V0, I'm going to find it straight away. That means 10 times 350. Right? Then what will happen? V0 we know 270. This is going to be 35. Meaning V10 will be 235. That's what it means by explicit. It still, makes sense, yes, common sense, that you are going to jump into that one. Right. Same thing we can apply for, same thing for opposite for the, linear growth as well. So technically, those are the ones that we could do. Yeah, then the geometric growth, that we'll do next time from 7D. Okay, guys, then thank you for coming today. Before you go, guys, you need the homework from the previous one, yes? You can do, guys, this one. Chapter 3, review questions. Sorry?
All of them.
All of them. Do you have MCQs? How many? 20? No, 23. And written questions you have 5. You have 6. Yeah. Try them. Thank you.